We apply our materials and applications expertise to manufacture high-performance, seamless mechanical tubing to meet our customers' needs. Our tube products thrive in demanding high-stress applications. The process of providing customers with our seamless mechanical tubing begins at one of three tube mills. Let's take a look at the number 5 tube mill and see how the operation works. Along the mill, each operator follows a precise setup sheet that helps produce the specified length, wall thickness, and outside diameter that we have engineered for a customer's order. At the charging table, we receive billets, or round pieces of steel, from the nearby Faircrest or Harrison plants. Here, we carefully count, market check the billets to make sure they have the correct heat number, outer diameter, and length for the order. Prior to loading, we also review the billets for any defects. We then convey the billets to a star wheel that positions each billet for insertion into a rotary hearth furnace for reheating. Before we can convert these billets to seamless mechanical tubing, a rotary hearth furnace must heat them up at temperatures ranging from 2,000 to 2,300 degrees Fahrenheit. The rotary furnace has 5 different heating zones and allows for us to heat different orders to different temperatures, depending on each grade of steel. We control the furnace by computer software that regulates heating requirements based on the billet size. Once we heat the billet to the proper temperature, we discharge it from the furnace and convey it to the center punch. We use a center punch to help ensure better wall concentricity during the piercing process. The center punch will hold the front end of the billet and then extend a punch into the billet's end to make this center indentation. This indentation also starts the piercing process. The piercing mill uses 2 barrel-shaped rolls, each driven by a motor with 3,000 horsepower capacity, to rotate the billet and force it over the piercing mill plug. A mandrel bar and bar steadiers hold this plug in place to achieve precise concentricity of the wall and outer diameter off of the piercing mill. The hollow tube formed off the piercing mill is now known as a pierced shell. Our number 5 tube mill uses an elongator mill to form the proper wall size for the customer. Wall size for the elongator mill runs from 0.430 inches up to 2.5 inches in 1/1000th of an inch increment. The cross-rolling action of the OD, forcing the hot shell down onto a mandrel bar on the shell inside, produces a smooth inner diameter surface and a precise concentricity along the tube's full length. The elongator also has the ability to skew or quickly open the work rolls. This allows for the mill to process an OD to wall ratio up to 13:1. In the next stage of our operation, we work to get a consistent outer diameter across the tube length by using a 10-stand reducing mill. Size ranges for this reducing mill range from 3.5 inches diameter up to 8.75 inches diameter. Like the versatility of our wall increments, the reducing mill can achieve any size within these dimensions, and we can produce orders in 1/1000th of an inch increment. We use different stands or reducing mill sets and adjust them according to the size requirements. Coming out of the reducing mill, there is a slight oval shape to the tube's dimension. We reduce this shape through a rotary sizer. This rotary sizer rounds the tube to a complete finished size. Since there is no internal support to the hollow tube, the rotary sizer uses minimal force to avoid damaging the tube. After exiting, we use a hot saw to cut 1-foot samples from the front, back, or center of the tube. Sampling frequencies vary depending on order, quantity, and requirements, but we use them to verify both dimensional aspects and surface conditions of the hot-rolled tube. The tubes then cool using a cooling bed or mill anneal furnace. The cooling bed rotates the hot-rolled tubes at a consistent pace to evenly cool the tube and maximize straightness. We can also use the mill anneal as a slow cool process to obtain desired microstructures for the tube. At the discharge area, operators identify, bale, tag, and call out for transport the finished hot-rolled tubes. Just like at the start of the mill, we must maintain proper sequencing, order count, and segregation of heat and order numbers to ensure proper identity exiting the mill. These tubes may continue for further processing, which could include thermal treatment, straightening, or other inspection processing after leaving the mill. From a billet to a shell to high-quality seamless mechanical tubing, contact us today to find out how our seamless mechanical tubing can exceed your expectations and help you push the bounds of what's possible.